Okay, so our mission for this deep dive is pretty specific, almost a bit meteorological. We're trying to figure out which sovereign nation on Earth actually gets the lowest amount of solar UV radiation each year. Where the sun's impact, the risk for skin damage is fundamentally the lowest.
Exactly. And when we say lowest amount, we need to be precise about the metric. We're looking for the lowest cumulative annual erythemally weighted UV dose. That sounds technical, but it basically means the total dose of the UV wavelengths that actually cause sunburn and long-term skin damage risk.
Yeah.
That's the key health measure.
Right, the stuff that matters for skin health.
Okay.
So how do we track that risk day to day? Is there a standard way?
There is, yeah. We use the Global Solar UV Index, the UVI. It's a standard scale, 0 up to 11 plus. Simple number. Generally, once it hits 3, that's when you need to start thinking about protection.
Okay, UVI 3 is the trigger point.
And here's where it gets interesting, because
Yeah.
the answer isn't just finding the country closest to the North Pole. It's more complicated than just latitude. Latitude is the starting point, definitely. As you go towards the poles, the sun is lower in the sky. Its rays hit at an oblique angle, so they travel through much more atmosphere. Think of it like a filter getting thicker. That slashes the intensity. Equatorial UVI can hit 20, but the high Arctic, it rarely gets above 8, even midsummer.
Okay, so the angle and atmosphere cut it down initially, but you said it's more complicated. What messes with that?
Two huge factors, and they pull in opposite directions. First, you've got cloud cover. We could call it the great attenuator.
The attenuator, okay, blocks the fun.
Yeah, thick clouds can cut the UV reaching the ground by 70% or even more. It's a massive shield.
But there's a counterforce?
Exactly. The UV multiplier, surface reflection, or what scientists call the albedo effect.
Right, and this is where snow comes in, and it sounds kind of counterintuitive.
It really is. Fresh snow is incredibly reflective for UV light, bouncing 80, maybe 90% of it back up. So suddenly you're getting zapped from the sun above and reflected UV from the ground below. It can almost double the dose your skin and eyes actually receive.
Wow, okay, so the lowest UV place is going to be where the clouds win out over the reflection on average over the whole year.
That's essentially the battle, yes.
Yeah.
Attenuation versus amplification.
So if we're looking at the high latitude contenders, Norway, Finland, Greenland seems like a prime candidate with all that ice. Which one comes out on top? Where's the balance tip?
Well, after synthesizing all the data, satellite measurements, ground observations, atmospheric modeling, the sovereign nation with the lowest average annual solar UV exposure is Iceland.
Iceland. Huh. That is genuinely surprising. I would have bet on Greenland. Why Iceland? It's not as far north, and Greenland has that massive permanent ice sheet for reflection.
It really boils down to one dominant factor. Iceland is defined by its extreme and incredibly persistent cloudiness. Its location, smack bang in the North Atlantic storm track, means its average annual cloud cover is staggeringly high, around 75%. Reykjavik, the capital, is one of the least sunny cities globally because of this.
So the clouds are just constantly there, acting like a permanent dimmer switch.
Pretty much. That consistent thick cloud deck effectively neutralizes the potential amplification from its snow cover. It dampens that albedo effect before it can really spike the UV levels, even during summer when the sun is higher.
Okay, so compared to Greenland. Greenland has the ice, sure, but maybe not the consistent cloud cover.
Exactly. Greenland, especially the vast interior ice sheet, is actually much higher altitude and significantly drier. This leads to more frequent clear sky days, particularly during the summer months when the sun is present 20/47 in some areas. So on those clear days, you get the high latitude sun combined with that intense reflection off the ice sheet. Those spikes in UV push Greenland's annual average dose higher than Iceland's persistently gloomy conditions.
Fascinating. So the gloom wins in terms of low UV. What does that mean for people living there health-wise? If you're in the world's lowest UV spot, what's the main health angle?
Well, the risk completely flips. You go from concerns about too much UV causing skin cancer to the very real risk of not enough UV, specifically for vitamin D.
Ah, right. Because you need UVB rays, the same ones that cause sunburn, to actually make vitamin D in your skin.
Precisely. And in Iceland, especially during the long winter months, say October through March, roughly the sun is just too low, the UVI is too weak. Even on a clear day, there simply isn't enough UVB intensity to trigger meaningful vitamin D production in the skin.
So relying on the sun just isn't an option for a big chunk of the year.
Not really, no. Public health guidance there strongly emphasizes getting vitamin D from your diet, fortified foods, oily fish, and, crucially, through regular supplementation. It's almost a requirement given the geography.
Right, a geographical reality dictating a behavioral or dietary need. Okay, so a final thought for you, our listeners, to consider. Even in Iceland, the place with the lowest annual average UV risk isn't zero. On a clear summer day, the UVI can still hit 3 or maybe 4, which is moderate risk. And imagine hiking on a glacier there in summer. You've got higher altitude, plus that intense snow reflection. You can definitely still get sunburned quickly in specific situations.
That's the crucial takeaway, really. Geography sets a baseline, and Iceland's is the lowest, which is scientifically interesting. But it doesn't eliminate the need for awareness.
Yep.
The most effective strategy universally is still behavior. Check the daily UV index forecast for where you are, and if it's 3 or higher, use protection. Seek shade, wear protective clothing, use sunscreen, don UV blocking sunglasses. That personal responsibility, that awareness is key no matter where on Earth you live.